This video is on graphing systems of inequalities. Yesterday, we looked at graphs of systems that were already done, and we learned how to write the inequality for that graph, or the system of inequalities. We also looked at the steps, and so on this screen is a recap of the steps to graph an inequality and the rules for solid and dashed lines and shading above and below. At the bottom here is also a reminder to watch for if you're putting it in slope-intercept form. Step 1, if it's not already in slope-intercept form, you have to be careful. If you multiply or divide by a negative, you have to flip the inequality symbol. So less than becomes greater than, or greater than becomes less than. You have these on a graphic organizer, and it might help to have that out in front of you now. Mostly this is about practice, and so we're going to do a problem together. You'll do one on your own, and we'll look at a couple of different ways you might see these inequalities. On this first one, you're asked to solve the system by showing a graph, and remember, this is all about the shaded region. We're going to graph each of these inequalities separately, but we will notice that there should be some overlapped shading, and that area, that region of the graph, is the solution to the system. And so we're going to start by graphing the first inequality, and I'm going to do it in red. You can make a sketch of the graph in this case and also write down the steps to do it so that you can follow them, because on the next screen you're going to try one. Remember, to graph any line, you need slope and y-intercept. And so for this first one, we're going to jot down what each of those is in this case. Slope is 5/2, and y-intercept is -2. Be very careful not to lose any negatives that might appear in the problem. And so if we start at the y-intercept of -2, and we go rise over run, up 5, right 2, we're here. And now before we draw that line in, we need to look at the inequality symbol. Do we want to make this a dashed or a solid line? Well, because there's an equal to underneath, we want to include the points on the line. And so we're going to make a solid line to indicate that. Make sure that your line covers the whole graph. Don't stop at your dots, because you're going to see that we're not sure where the shading is going to overlap. So the next part is the shading. What part do I want to shade? Above the line or below the line? Well, again, we look at our inequality symbol. I see less than. Less than tells me below. And so I can go ahead and shade, if it'll let me, the region below the line. Okay, so this whole thing should be shaded here. I don't know why it's not doing everything. All right, I'm going to use a different color for the second one. And again, I'm looking at this equation. I know to graph, or inequality, to graph it, I need slope and y-intercept. The slope in this case is 1/2, and the y-intercept is +2. And so I start at the y-intercept, I make a dot, and then I use my slope from that y-intercept as a set of directions to get to the next dot or point on that line. This tells me up 1, right 2. So up 1, right 2. And I might do that again just to see where I'm landing here. Or even down 1 and left 2 to get the full effect. I need to decide whether my line is dashed or solid. So I look at the symbol and I see that there's an equal to underneath. So again, in this case, it means a solid line. Looks like I have a delay here. My line's not great, but you get the idea. Okay, And I need to decide whether to shade above or below. And so I look and my symbol is greater than. Is greater than above or below the line? Greater than is above, and so that means that you're shading all of this. And so what we're really interested in is the overlap. And I hope you can see that we're not really overlapping until we're up here in this part of the graph. If I extended my blue line and I extended my red line, I would see that this piece or something, if it wants to let me, to show that that's where the overlap would be. And that's the part I'm interested in for solving a system of equations. So usually this will land on the graph, but it is possible that the overlapped region would be sort of off the graph. Let's look at the next one. I'd like you to use your own graph paper and practice graphing both of these on the same coordinate plane. Now, if you don't have graph paper, pull out one of your worksheets with graphs on it and use it as a guide. You can write on a graph that's already used if you have to. Pause the video, practice this now, and when you come back, we'll see how you did. All right, how'd you do? It's a little hard to look at on the screen. It's probably much prettier on your page, shaded with pencil. But my first inequality was done in blue and included everything below the blue line. The second inequality was done in red and included everything above this dashed red line, which is hard to see on here, I know. But it should be a dashed line because there's no equal to. I highlighted in yellow the overlapped shading so that you could compare it to what you have to see if you have the right region overlapped. And this is what the solution to a system of equations looks like. Here's a question. Is the point 4, 1 a solution to this system? Well, to determine that, you find the point 4, 1 on the graph and you look to see if it's part of the overlapped region. If it is a solution to the system. But if it's only on one part of the shading or no shading at all, then it's not a solution to the system. For a system of inequalities, a point is a solution if it's in the overlapped shaded region. The next one that we're going to look at is one that's not already in slope-intercept form. And so it's important for you to put each of these inequalities in slope-intercept form and then graph them the way we did in the last slide. I want you to pause the video and take a moment and put each of these in slope-intercept form now. Don't graph them yet. Let's check that you've put them in that form properly before you get to the graph. How'd you do? I hope you were careful. This 3x needs to be subtracted. Don't lose that negative. And this 3 stays negative, so don't let that go away. In the second equation, it took 2 steps. You move the x first, and so minus x goes to the right side of the inequality. But don't forget to get the y by itself, which means dividing everything by 2. Keep in mind that there is an understood 1 in front of that x. And so it's a negative 1 in this case. And when you divide by 2, you end up with negative 1/2. 4 divided by that 2 reduces to 2. And so if you lost one of those, that's where it is. All right, so again, if you've got these or if you've now corrected them, let's take a second and graph it on a graph that you have. Come back to me when you think you've got it, and let's see how you did. Pause the video. Check your work. How'd you do? Again, I use the highlighter to highlight the region that should be overlapped shading. The first inequality I graphed in red, and you can see a dashed line and the shading above the line. The second inequality I did in blue, and that's this dashed line, again because there's no equal to underneath the inequality symbol. And my shading happened below the blue line. The overlap was this yellow highlighted region. Is the point 0, 0 a solution to this system of equations? Or inequalities, I'm sorry. I hope you said the answer is yes. Because the point 0, 0 is in the shaded region, it is a solution to the system. We're going to skip this one and briefly talk about horizontal and vertical lines. Horizontal lines will always be in the form y equals some number, like the picture shown here. A horizontal line goes across like the horizon, and this one is y equals -1. Vertical lines will always be in the form x equals some number, and this is a vertical line, and it has the equation x equals 2. Notice there's only one variable, one letter, for a horizontal or a vertical line. Using the graphs, can you come up with a way of remembering this using x equals for a vertical and y equals for a horizontal, and how you know what number belongs there? I want you to write it down, and I'm going to be asking you to share your idea with the class tomorrow.